Hey guys, welcome back to our next lesson. In this lesson, we are going to take the absolute value, f of x equals the absolute value of x, and we're going to answer the following questions. So in this problem here, I'm going to ask you guys to create a table of values from at least -3 to +3, and you can do more, but just so we can get an idea of what this looks like, okay? So we're going to have -3, -2, -1, 0, 1, 2, 3. And basically what happens with this is that anything that goes into this absolute value will come back positive. Even the positive will come back positive, right? So you put a -3 in, you get 3. You put a -2 in, you get a 2. 1, 0, 1, 2, and 3. So a lot of you already know what this looks like from algebra, but I'm going to create a rough sketch. 1, 2, 3, 1, 2, -3. At 1, 1, 2, 2, 3, 3, 0, 0, -1, 1, -2, 2, -3, 3. And then what I'm going to do here is I'm going to just get an idea of what this picture looks like, and everybody should know it looks like a V. And it keeps going. I wrote here, does this function appear to be continuous? Basically, the way that you could think of continuity is that, can I draw this picture without picking up my pen? And the answer to that question is absolutely. You can draw this without ever picking up your pen, right? So what would an idea of a discontinuous function? Well, I'm not going to get too involved in it, but basically, if I look at a function like this, I cannot draw this without picking up my pen to get over here. So this is discontinuous, okay? This is a continuous function. And what that means is basically, what can I say about the domain? I can put any x value in there and nothing will mess up my graph. So my domain is -infinity to infinity. There are no holes, no asymptotes, no jumps. It works for every single number, okay? And the third part of this, I said, discuss the symmetry. Well, this here is the y-axis, and this is symmetrical with respect to the y-axis. When a function is symmetrical with the y-axis, we know that it's an even function, okay? So here, I wrote, show algebraically if it's whether the function's even, odd, or neither. Well, I just finished saying that the function is even. And the way that we show whether it's even or odd is the same procedure. You plug in a -x everywhere you see an x. And the absolute value of a negative is a positive. And you got back the same function. When you plug in a -x and you get back your answer, right, this absolute value, and it matches your original function, then we're going to say since the negative matches the original is an even function. Pause the video if I'm going too fast, rewatch it, take notes if you need to. So that's how you show it's even. I wrote discuss the end behavior. So I'm going to have to draw a quick sketch again. This is what this looks like. And I want you to understand one thing here. This is positive. This is x, right? This is negative. This is. And then here, that's -infinity. So what happens when we discuss end behavior? We say what happens as x approaches infinity and what happens when x approaches -infinity. Where is the graph going in the y direction? Well, when we go this way, my graph is going up. When we go this way, my graph is going up as well. So in both directions, I'm heading to infinity. In my next problem, I say, what is the range of each function? The range is the y value. So what's my lowest y and what's my highest y? My lowest y is 0. So my range, where can I write this? I'm going to write it in black, and I will write it here. The range is from 0, including 0, to infinity, or you can also write it like this, okay? So 0 is the lowest, and then it keeps going up. I wrote, on what interval is the function increasing, decreasing, and what is the max and min? Sorry. Okay. So where am I increasing means where do I have a positive slope? So that's going to be from 0. These are all positive slopes. Sorry about the noise. And where is the function decreasing? Decreasing means where do I have a negative slope? So this is negative, these slopes. So I'm decreasing from negative infinity to 0. A common question is, how come we put negative infinity before 0? Well, here's 0, here's 1, here's 2, here's 3. Down here might be 50, down here might be 5 million, and so on. Let's just put infinity there. We do it from left to right, so that's 0 to infinity. Here is negative 1, negative 2. Here's negative infinity. We do it from left to right. So it's negative infinity to 0. I wrote, is there a relative maximum or minimum? Yeah. If I go down and then I come back up, I hit a minimum. You want to write it as a point. So there's a relative min at the point 0, 0. I will just leave this alone about concavity. In order for something to have a point of, in order for a function to have a point of inflection, the concavity has to switch. And when you think of concavity, you're thinking about smoothness. Do I see concaved up like a U? Or concave down like almost an A? Is it smooth? Well, this is a sharp turn. So there is no concavity. It's not going to be concaved up or down here. Okay? So let's just leave that alone. And here is the last part of this problem. So here is this, here is this. As 0, 0, let's get some different colors. 1 is 1, 2 is 2, 3 is, I'm going to call it 3. Negative 1, negative 2, negative 3 is also 3. Okay? I wrote, I'm going to just get rid of this. I wrote, find the area of the region that is enclosed by the line x equal negative 3, x equals positive 3, the x-axis, and the function. So remember, x equals is a vertical line. So x equals negative 3 is this line. X equals positive 3 is this line. The x-axis is this. And then the function itself. Once again, area enclosed by negative 3, positive 3, x-axis, and the function. So I want to figure out what the area is for these two triangles. And that's literally what we do. We say area of the triangle is 1/2 base times height. The base is 3 units this way. The height is 3 units this way. And so this is going to be 1/2 3 times 3. Similarly, this is going to be 1/2 3 times 3. So this is going to be 9/2 for this one, and this is going to be 9/2 for this one. Well, 9/2 and 9/2 makes 18/2, which is really just equal to 9. Okay? So that's how we figure out these areas. So this is 9. And then here, I just want to show you the notation of how to do this, okay? In calculus, we basically ask this question without all of these words. What we do is we say sorry. What we say here is, what is the area? And so this translates like this. We don't put the x equals because we already know that it's x. We don't put the y equals because we know that the function y has to go there. Okay, so that's like the worst thing I can do right now because it's giving me. We have to put it with respect to x. And this here just means area. This is a long integral sign. This says integrate between -3 and 3, the function absolute value of x. So this here is basically asking you to find the area from -3 to 3. So I wrote calculate the area between two values. So what we do is we put the lower bound. So this is called lower. And this is called upper. And that's because I want it from here to here. You put the function and you put dx. Now, this dx needs to be there. I'll explain it at some point in many, many later videos what it means. But right now, this is the proper way of asking you to find the area that's enclosed between -3 and 3, the x-axis and the function. So it's this long s. It's called integral. So let me write that for you. And that's pretty much it for today's lesson, okay? So take your time, rewatch the video, slow it down, and take notes. Have a great day.